Today we are in section 2-7 and we're talking about absolute value functions and their graphs. So the parent functions of our absolute value graphs are just y equals the absolute value of x, okay? So it's the simplest form. You're not moving it left, right, up or down, reflecting it, or doing any stretching or compression. So for a lot of you guys, you may not know how to graph y equals the absolute value of x. So to find out, I'm going to create a table of values, and I am going to randomly pick some negative numbers and some positive numbers, so that way we have a good idea of what our graph looks like. So you take the x values, and again you're going to plug them into your parent function. So the absolute value of -2 is +2. The absolute value of -1 is +1. The absolute value of 0 is 0. The absolute value of 1, 1. The absolute value of 2, 2. Now let's graph those points. So -2, +2, -1, +1, 0, 0, 1, 1, and then 2, 2. Okay? And if you connect your points, your graph should look like a V. They are two straight lines that intersect at one point. The point where they intersect is called the vertex. And then there is this invisible line that cuts your V in half, and it is called your axis of symmetry. And I will always shorthand the axis of symmetry to AOS. The general form for the absolute value graph is y equals A times the absolute value of x plus or minus h, and then plus or minus k as well. And this is where we are going to get our shifting from. So the A, just like before, if A is greater than 1, it's going to be a vertical stretch. And again, I shorthand that to VS. If A is greater than 0 but less than 1, that's going to be a vertical compression. And if there's a negative sign out in front of A, that's going to reflect it across your x-axis. Okay, so the plus h is inside my absolute value bars, so plus h is actually going to move it to the left. Minus h is going to actually move your graph to the right. Plus a number at the end, plus k, is going to move your graph up. Minus k is going to move your graph down. Again, this is just like section 2.6. Now, to find the vertex of these shifted graphs, it's h, k. The axis of symmetry is always going to be x equals your h value, and then we're going to add domain and range. Now let's talk about the domain and range. So if you remember the parent function, your graph looks like this. Domain is your x values, and are those arrows ever going to stop your graph from growing from left to right? And hopefully you answer the question no, so your domain is always going to be -infinity to +infinity. Now, based on the way your graph is shifted, your range is going to go from k to infinity, or if it's -a, if it's being reflected over your x-axis, then it's going to switch that around and it's going to make it -infinity to k, and it's going to stop there because k is either your lowest point or your highest point of your graph. Alright, now let's also come back up here and let's talk about A, okay? So A is going to be your vertical stretch or your vertical compression, and since we're talking about two straight lines that meet at the vertex, A is also going to be the slope that we're going to graph from the vertex. In example 1, let's graph and state the characteristics of y equals the absolute value of x plus 3 minus 2. Okay, so thinking back to section 2.6, plus 3 that's inside your absolute value bars is going to move our graph to the left 3. The minus 2 at the end is going to move your graph down 2. Okay, and then A, the number out in front, A is just equal to 1, and we're going to need that later for our slope. So the vertex, if it was shifted to the left 3 and then down 2, the vertex is -3, -2. My axis of symmetry, x equals the h part of your vertex, the x part of your vertex, so x equals -3. The domain, again, since those arrows are never going to stop growing, it's going to be -infinity to +infinity. Our range, A is positive, so that's a good thing. K is -2, so it's -2 to infinity. Okay, let's start to draw this graph. We're going to first start by graphing our vertex. So -3, -2. Okay, the slope is +1, so to get to my next point from my vertex, I go up 1 into the right one, and then I also have to go up 1 into the left one so that I can get the negative side of my graph. So then from those two dots, do the same thing, go up 1 into the right one, and then go up 1 into the left one. Okay, and now you can see your V really nicely. And your graph looks like so. I want you guys to try this problem, so press pause, and I want you to graph y equals the absolute value of x minus 4 plus 1, and I also want you to state the characteristics. Okay, -4, since it's inside my absolute value bars, is going to end up moving it to the right 4. The +1 at the end is going to move it up 1. So if that's the case, right 4 and up 1 is going to make the vertex at 4, 1, which is going to make the axis of symmetry at x equals 4. The domain, same as always, -infinity to +infinity. It's never going to stop growing. Range, check to see if A is positive, which it is. So it's my k value to infinity. Alright, let's start to graph this. Let's pay attention to the fact that A is +1, that's my slope. And let's graph the vertex first. So we graph 4, 1. And then from that point, I go up 1 and right 1 because my slope is +1. And I go up 1 and left 1 so that I can get both sides of my graph. And then we're going to do that one more time so that we can get a good look at our graph. So from the pink dots, go up 1 into the right one, and then up 1 into the left one. Okay, so now connect them to make your V, and your graph looks like so. So now let's see what happens when we add a vertical stretch or compression to the mix. So in example 3, we're going to look at y equals 2 times the absolute value of x minus 1 plus 3. And I'm going to start by identifying everything. So 2 is greater than 1, which means it's going to be a vertical stretch by a factor of 2. Minus 1 is going to end up moving my graph to the right 1. And plus 3 is going to end up moving my graph up 3. So let's start by talking about our vertex. So if I move my point to the right 1 and up 3, my vertex should be at 1, 3. My axis of symmetry is x equals the x part of my vertex, so x equals 1. Then my domain, always going to be -infinity to +infinity because it's never going to stop growing. The range, okay, A is +2, so that means it's going to be from k, so the y part, so from 3 to infinity. So let's start by graphing our vertex. So 1, +3. Now, from that point, we move the slope. Okay, so since A is +2, that means you're going to go up 2 and to the right 1 to get your first dot, and up 2 and to the left 1. Okay, so you can get both sides of your V. Then from that point, you are going to do the exact same thing again. So from my pink dot, I go up 2 and to the right 1. Okay, and then from this pink dot, up 2 and to the left one. And then make your V. All right, try this last example, guys. I want you to graph it and state the characteristics for y equals negative 1/2 times the absolute value of x plus 3 minus 2. The negative out in front makes your absolute value bars flip over the x-axis. The 1/2 is a vertical compression. The plus 3 moves it to the left 3, and the minus 2 moves it down 2. So that is going to make my vertex, since it was being moved to the left, minus 3, and down 2 makes it minus 2. The axis of symmetry is x equals the x part of your vertex, so negative 3. Domain, even though it's negative, still is going to be negative infinity to positive infinity. Now the range, this is where it's different. So since a is negative, it's going to make it negative infinity now to k, so negative 2, because now it's been flipped over. So k is now the highest part of our graph. So let's graph negative 3, negative 2. Okay, so now normally I would go up 1 and to the right 2, but since it's negative, that means I am going to go down 1 and to the right 2, and I am going to go down 1 and to the left 2. And then from those two pink dots, you're going to do the exact same thing again. You are going to go from the pink dot down 1 and to the right 2, and then down 1 and to the left 2. And then make your V like so.